All right, so for today, it's kind of like what we did yesterday about exponentials. What was the most simple exponential that we had? Y equals 2 to the x. And then we said that that would be what? Growth or decay? That'd be growth. What if I made it 0.2 to the x? Do you get you'd be multiplying 0.2 over and over and over again? Is that going to be growth or decay? Decay. That's going to get smaller and smaller and smaller because you keep multiplying by 0.2. It gets smaller and smaller. All right. And then I wrote some out like this. Y equals 6 times 2 to the x. And then I said that the starting value, what's the starting value for this one? Say it if you know it. 6. And is it growth or decay, judging by that 2 in there? Growth. And then what's this supposed to be? It starts with a T. Time. All right. So then I wrote them like this. Y equals, let's say 5, and then 1 plus 0.2 to the x. And then I said, is this growth or decay? Parker, which one was it? Because why? Yeah, but if they add 1 plus 0.2, it's 1.2. So it's actually growth. Okay. So whenever you do this 1 plus thing, you look for that. And if it's plus 1, 1 plus something, then it's growth. If that had been a minus, it'd be decay. This is called the growth rate. And when this is all put together, that adds up to 1.2. 1.2 is called the common ratio. That's a new word you're learning today. Common ratio. Okay, so there's something called the growth rate. There's something called the common ratio. Do you get that the growth rate is in the common ratio? They're put together. Like this is inside of the common ratio. All right, so let me do another common ratio question. This is supposed to be an easy question. It will be eventually when we take a test. If I gave you this problem, 50 times 0.85 to the x, I encourage you to always rewrite these like this. And then you go 1 minus 0.15. Because this way is better. Why is that way better? Because it tells me that it's decay because of the minus. And it tells me the growth or decay rate is the 15%. So this is the rate. And here this means that it's decay. But the common ratio is when you put it all together. So I'm going to highlight and say this part all together makes this. They're the same thing. 1 minus 15 cents is 85 cents. So they're all the same, but this one's called the common ratio. And I want to show you an example of why they're called a ratio. If I said 2, and then 4, and then 8, and then 16, do you get what's happening here? It's doubling every time, right? So what a ratio means is like 4 over 2 is the common ratio. Quite late there, youngster. Still here on time enough to make Mark present, but if you're a little later, it'd been absent. Okay, so this 8 divided by 4, also the common ratio. Get it? They always come out to 2. So the common ratio is what you get when you divide those two numbers. So if I said, what's my starting amount? I hope you'd know it was 2. Y equals 2. And then I hope you know it's doubling. That's why that's a 2 right there. And then it's to the x. That's called an exponential equation with a start value of 2. And guess what happens if I put in like a 1 here? Well, then I get 2 times 2, which is 4 for the first term. Guess what happens when I put in a 2 here? 2 squared is 4 times 2 is 8. And look at that. It'd come out with the next one, and then it'll just keep doing that. See what I mean? Okay, so that's called an exponential. That's growth because this is bigger than 1. It's got a start value of 2. And the common ratio was 2. Whatever's in there, the base of it, is the common ratio. Because if we look again at this problem here, see how it's always times 2, times 2, times 2? That's the ratio between them then. And that's going to be this number. But yet, it's one of those like super easy questions, but a hard question. So if I give you a problem like this, I guarantee you somebody will be totally lost when I ask, is this growth? If it's not, say what it is. What's the start value? I didn't make it super clear, but you should be able to figure it out. What's the common ratio? That's all of it together, whatever the base is, all together. And then what's the growth / decay rate? So I've told you everything, but I'm not sure you're really getting it until you can answer these 4 questions. If you can answer these 4 questions, then I will believe that you really understand this whole exponential thing. Okay, JP, tell me one thing you think you know from this. Tyler, be pondering these things so I can call on you too. Yes?
It's decay.
It is decay. And how did you know it was decay? Yeah, it's being multiplied by something less than 1. So this was not growth, it was decay. Very good. Next. To know what's the starting value the way I wrote this problem? This is a tough question.
No, I wasn't paying attention.
Thank you for being honest. Since there's nothing in front here other than a 1, the number that's in front, that's the starting value. Okay? And then this is the base, also known as the common ratio. So that's the starting value, 1. Okay. Next up, J. James, the common ratio.
0.75.
You got it. And then the decay rate, and it's really common for people to think it's 0.75 and they're wrong. How much is it going down? I suggested that you rewrite it like this, 1 minus something. Because you can make this and this be the exact same, and this one was the common ratio. So I know I'm kind of spoon feeding you this one, but this should have been a 0.25. Who had 0.25? Okay, good. So that was the decay rate, is 0.25. Does that make sense? Okay. So I've been doing the hard work to teach you all of this stuff ahead of time so that when we get to that part of the unit, you're going to be like, oh, that's easy. It's just some terminology. One more like that. Y equals 7 times 1 plus 0.27 to the x. I'd like to know, is this growth or decay? What is the common ratio? What's the growth rate? And what's the starting value? Taylor, tell me, is it growth or decay?
Growth.
Prove it. Yeah, you're adding to the 1, so it's going to be bigger than 1, so it's growth. Good. Okay. I'll take a volunteer so I don't have to embarrass anybody. What's common ratio here? Oh, come on. All right, then I'll call on a random person. I'll get my dice out so that I'm not picking out anybody. row 2. Last person, Lydia. What do you think the common ratio is? 1.27. Yep, it's that whole thing put together. All right, Eddie, what do you think the growth rate is?
.73.
No, it's point something, and it's in the problem, and it's on the board, but
27.
there you go, 0.27. That's the growth rate. If you asked for a percent, I'd say 27%, but I never said you had to do that, so. All right, and then starting value. Stella Dalkey, what was the start value in this problem? Yes, it would be 7. So if you had 7 llamas, and you were told that if you treated them well, fed them, took care of them, that they would grow in population of your little herd by 27%. That's what this would look like. And then after, let's say, 5 years, how many llamas do you have? You put a 5 right there, and you'd be able to use a calculator. 7 times 1.27 to the power of 5. Okay, I feel like you're getting this. So then, do you remember when we had these problems, and then we said like, oh, but I want a +3. Do you remember where that moves? I know it obviously has to do with the 3, but is it going to be right or left 3, or is it up or down 3? Sage.
Left 3.
It is left 3. So when it's inside with the x, then it's left or right, and it's the opposite of what you would think, because +3 feels like it's to the right, because that's where the positive numbers are, but it's actually left, so it's always opposite of what you'd think in there. This is like that because you'll have things like this, but then I go, but I want to move it +7. If it's in with the x, you could put this in a parentheses, couldn't you? So it's inside a parentheses. So again, you don't trust it. That seems like it's moving to the right 7. So it's actually left 7. And then if I put a +8 out here, that's on the outside. And if you remember, it's horizontal on the inside and vertical on the outside. That's on the outside. This is confusing to say what's on the inside, but definitely this looks more inside than the other stuff does. And I always have said inside by the x. So the stuff in there, that's left and right moves. All right, now I think we're ready to fly through the notes as they're written, and they should feel easy now. Horizontal on the inside, so the left and right stuff is on the inside. Remember, on an exponential, inside is by the x. So like that right there, that's an inside move. On the outside would be like this. 4 to the x, but then +7. That's outside. And that means that's a vertical move, as in up 7. Okay, so then they give you this, and they say, describe the transformations and then graph it. Okay, describe the transformations, is this left or right too? Say it. Left. And then what's this 5? Up or down? That's up. And then if you're going to graph this, do you get how to graph points? Okay, that's a little too easy. I'm sorry, this is just a little too simplistic. I know you'd be able to graph those points. More difficult, normal question would be, I give you a blank chart and you have to fill it in. So by the end of this lesson, you'll be able to describe and graph translated, that means moved, exponential graphs using the same rules from semester 1. Okay, so here's one. Which way does it go? Left or right or up or down? It is row 1, last person. Atis. Right 1, correct. Next one, Stella Dalkey. Up 1. Next one, JP. Down 2. What's different about this one is it's got a fraction in there. That means that it's exponential decay. So that graph generally would look like this. Do you remember these graphs from yesterday? and then it would move down 2 from there. This one, same thing. It would generally look like this. But then this happened. This +4 right there. Noah, is that +4 going to move it up, down, left, or right? Hint, it's on the inside. Left is correct. All right. Now we're going to go to this one. Row 3. Fourth person, Sage, that's you. This is moving 2 ways. Can you tell me what they are? Left 1, down 3. You are correct. I think you got the idea there. So this one's decay, right 2, up 6. This all making sense? Okay, then a typical question looks like this. You get a blank chart. You're supposed to graph it. Do you have to have it memorized? Well, I kind of know it looks like this because it's growth. And I kind of know it's when moved up 1. But how do I get the rest of the stuff? You get exact points. You put in any number you want. So, row 2, last person, Lydia, give me a X number and I'll put it in. Just keep it nice because I don't want to be complicated. Good. If I put in 1, Lydia, 3 to the 1 plus 1. That's going to be 4. So 1 comma 4. So I start graphing and I go over 1 up 4, put a dot. Okay. Eddie, give me a number.
2.
Put it in and I get it there. And then what do I get?
9.
Plus 1? 10. 2 over 2 up 10. And I can tell it's going to go off the graph. If I go to 3, it's going to be too big. So J. James, don't go to 3. Do something else. You're giving me an X number for right here.
1.
We already did 1. -1. That could work. So now, talk me through it, Jay. 3 to the -1. We did these yesterday. It'd be easy to forget, but do you remember what that does to the 3 when you put a -1 power on it?
-3.
Nope. 1/3. This makes 1/3. Plus 1 is 1 and 1/3. So any number, like if I have 5 to the -1, makes 1/5. I like to think of it as flipping the number over. And if I had a 5 and I flipped it over, it'd be 1/5. So that's what -1 powers do. Okay, so back to my points. Do you get I can graph these 3 points? All right, then the one thing I don't have is the asymptote. Normal asymptote would be here. Try to remember that. There's only one asymptote for these things. It's right there. It's like the ground level. But do you agree this one got moved up? Because of that +1. So do you get that it's now where this blue dotted line is? Then that's the asymptote. Now, we had a test on this, but I get it's easy to forget. It's going through this spot right here. Is that X equals 1 or Y equals 1? That blue line, the horizontal asymptote, is it X equals 1 or Y equals 1? You have to take a side. It's one or the other. Taylor. All right. That spot right there, my friend, is Y equals 1. So it's Y equals 1. Okay. I know those are easy to confuse. Try to think of what place it goes through. So if I had said like this, you'd say, oh, it went through here. That's X equals 6. So then the line would be X equals 6. It's whatever it goes through. That's its name. Okay? So this would be X equals 6. This would be Y equals 1. That make more sense? Okay. All right, here I got another good one for you. They're all horizontal asymptotes. That means they're all horizontal asymptotes. You remember that? So they're all Y equals things. Every one of them. We don't have any asymptotes that go up and down in this unit. Just this way. So they're all horizontals. They're all Y equals. Okay? All right. Almost done, ladies and gentlemen. And we'll have lots of time left for you to get your homework done. Walk out of here with no homework this weekend, which would be fantastic. Eddie, pick a number. Easiest question I can ask you.
14.
So you want to do 2 to the 14th?
Oh, 3.
Okay. All right, 2 to the 3rd will work. 2 to the 3rd, can you do it in your head?
Yeah.
What is it?
8.
Minus 1 is 7. 3, 7 is one of your points. Now find 2 more. Graph it. And remember what it is. It looks like this. It's just we're finding exact points for it. And oh yeah, don't forget, the asymptote that would have been here gets moved down 1. So you can tell by that number outside whether or not your asymptote, which used to be at the horizontal asymptote, y equals 0. They always start at y equals 0 unless they get moved like this. So where is the horizontal asymptote? Y equals, it moves down 1, negative 1. So I'm going to finish this one up. You see if you would got the same thing as I would have got. The asymptote's at negative 1 because it got moved down 1 because of that. Oh man, I kept seeing that as outside. That's not on the outside. Oh, thank you. That's on the inside. And the number is too big. I know, I'm making excuses, but it's true. That's all on the inside. So that's actually a move to the right one. So I'm wrong. The asymptote, if I budge this line over and it used to be here and I move it to the right, do you get I'll never be able to even tell I moved it? So it's still at y equals 0. My bad. Thank you for catching that, Eddie. Y equals 0. Okay, now I got to get a few more points. That was the easiest thing we ever did, was stick in a number, so let's stick in another number. I'm going to ask you to put in 2, Sage. Tell me what you get. Walk me through it. We put a 2 right there. But wait. 2 to the 2 minus 1. So don't do 2 to the 2nd. You got to do the 2 minus 1 first. You know why? Because it's in parentheses. That has to be done first. So don't get 2 to the 2nd as 4. Do 2 minus 1 is 1, and then keep going from there. Yes, it would be. So 2 comma 2. Max, give me another number to put in for x.
1.
Putting a 1 right there, putting a 1 right there. Talk me through it, Max.
2 to 0.
2 to the 0, which is?
1.
1. So now I graph these points. 1, 1. 2, 2. And 3, 7. Uh-oh.
I don't think 3, 7 is the right point.
Okay, double checking. Oh, because I thought it was on the outside back then, didn't I? I think you're right. So putting in a 3 right here. Because I had this in my head that was on the outside the whole time, but it's not. Thank you. So, Olivia, can you tell me what it actually should be?
4.
All right, so we're going to go 2 to the 3rd is... I think it's not 4, though. No, wait. I keep doing 2 to the 3rd. It's 2 to the 3 minus 1. And the 3 minus 1 is really 2. 2 to the 2 is 4. There you go. 3, comma 4. Thank you for fixing that. Whew. 1, 2, 3, 2, 3, 4. It's there, not there. Okay, cool. Now, how many points do you need for these? As long as you can see the curve, which I can. I know it has to get closer and closer to the asymptote. That's called asymptotic behavior. It's kind of like a moth flies closer and closer to a flame. They just get attracted to the light. They can't help themselves. This gets attracted to the asymptote. So if you kept on making points further and further to the left, they would just get closer and closer and closer to 0, but they wouldn't actually touch 0. So there. Was the asymptote? It never moved. You know how I know it never moved? Because there was nothing on the outside. I thought there was, but that's not on the outside. If I'd have written that, I'd have written it more like this. To make it really obvious that that power is where the thing is moved. Okay. All the rest of them are just problems that are just like repeats. I'm just gonna do this one super fast to show you one that's decay. I'm gonna put in a 1. Anything to the 1 power is just itself. And 1/2 minus 2 is negative 1 and 1/2. Then I'm gonna put in the 0 power. It's my favorite thing. If I put in x is 0. And then I got 1/2 to the 0, which is 1. 1 minus 2, negative 1. Then I'm gonna put in 2. 1/2 squared is 1 squared over 2 squared, which is 1/4. 1/4 minus 2 is negative 1 and 1/4. If those negative numbers annoy you, sorry, but you're going to have to deal with some decimals every now and then. So 0 comma negative 1 is there. 1 comma negative 1.5 is there. And 2 comma negative 1 and 1/4 is there. And I'm feeling like something's wrong. Oh, this is decay, so it's supposed to look a little weird. 1 comma negative 1.5 is right. 0 comma negative 1 is right. 2 comma negative 1 and 1/4. That's the one that's messing me up. 3/4. There it is. I made a mistake on this one. I was trying to do it too fast in my head. This is 1 3/4. So that's why. See, the good part is I didn't just trust the dots. I knew something was wrong because I know how these are supposed to look. You know, they're supposed to look like that. Except this one's moved down 2. So do you get how the dots are lower? And that makes sense to me. So then the asymptote, which normally would be at 0, 0, has been moved down here, and that's why it's getting like really, really close, but not touching there. And then it goes up like that. Would this have been enough points? Yes, 3 points with the asymptote in the right place at y equals negative 2 would have been enough. Your asymptotes are your horizontal asymptotes are always y equals things. Okay, I feel like I've done enough practice with you that you could have caught on by now, but you know I like to help one-on-one. So today during work time, please feel free to come up. There are a lot of problems, and I think I'm going to cut it down a bit, try to make it more realistic to get it all done, trying to keep you from like going, oh, math sucks, there's too much homework. So I'm trying to keep it very reasonable so you don't quit doing it. I know some of you, I can't probably help with that, but the vast majority have been doing your homework, so that's awesome. So this is the part where I'd love to tell people on the video which problems they can skip in their homework. So I'm going to pause for a sec, everybody get the worksheet up, and then show me so I can tell you which ones to skip. For today's assignment, because it's labeled 1 ABC and 2 ABC, we're going to skip 1C and 2C. Cross those off. Question number 1. Olivia, would you please read what I'm supposed to graph?
2 to the x plus 3.
And the plus 3, is that in with the x?
No, it's...
Down low?
Yeah.
Okay. Then, XY chart. Graph. First thing I'd graph is to kind of sketch it and go, this is just for me to kind of know where it should sort of be. Should sort of be like that, but up 3. So then it probably more like up there. I know it's kind of supposed to look like that. But is that good enough for the test? Of course not. You got to get exact numbers. I put in 1, and I get 2 to the 1 is 2, plus 3 is 5. I put in 2, and I get 2 squared is 4, plus 3 is 7. And I put in 0, and I get 2 to the 0 is 1, 1 plus 3 is 4. And then I graph those points. Over 1 up 5, over 2 up 7, over 0 up 4. Look at that, I was generally in the right place. And then where is the asymptote? Normally they're here, but is it still there? Max, where do you think it's been moved to? The red asymptote there would have been y equals 0, but it's moved. give you a hint. This is where it moved. What does that mean? Left, right, up, or down 3?
Up 3.
Up 3. So the new asymptote is there at y equals 3. That's the horizontal asymptote for you. Okay, there's some pretty direct instruction. I hope that that's enough that you understand this. And you could also be asked things like, is this growth or decay? And you'd go, oh, since there's a 2 in here, this one's growth. What was the starting value? Well, technically, it would be at 1 because there's nothing in front of this 2. So if I was going to say anything, it's like 1 times 2 to the x. So there's a starting value of 1. And then where is the asymptote? Well, the horizontal asymptote would be at 3. Y equals 3. It's and the common ratio would have been 2. And the growth rate, this is a tricky one. The growth rate would have been 100%. Why would the growth rate be 100%? Because look, would you agree that's the same as 1 plus 1 to the x? Doesn't that make it easier to see that the growth rate is 100%? That's a tricky one, but some of you might have got it. All right, that's all I have for you for today.